Good morning. Myself, P. Vanita, working as assistant professor at the Department of Electrical and Electronics Engineering. Today, we are going to study an important topic in measurements and instrumentation, uh, that is the errors in measurement. In practical measurements, we never get the exact true value. There will always be some difference between the measured value and the true value. This difference is called error. Understanding errors is very important because in electrical and electronics measurements, even a small error can cause wrong calculation. So in this lecture, we will see the causes of errors, types of errors, and how we reduce errors using statistical methods. Let us first see the causes of errors. Errors may occur due to different reasons. One major cause is the instrument itself. For example, if an ammeter is not properly calibrated, it will show wrong current value. Another cause is the environmental condition. Temperature, humidity, pressure, vibration, and magnetic fields can affect measurement. Next, um, uh, is observational error. This happens when the person reading the instrument makes the mistakes such as parallax error in analog meters. So errors can be caused by instrument defects in environment and human observation. Based on their nature, errors are classified into two main types. Systematic errors follow a fixed pattern and can be predicted. Random errors, uh, random errors do not follow any patterns and they change randomly from one reading to another. Let us study each type in detail. Systematic error is an error which occurs repeatedly in the same direction. For example, if your voltmeter always shows 2 volts, then that is a systematic error. These errors occur due to three main reasons. First, instrumental error, which is due to defects in the instrument like friction, aging of components, or rank validation. Second is the environmental error, caused by temperature variation, humidity, dust, or stray magnetic field. Third is observational error, such as parallax error, when reading the scale. The advantages of systematic error is that can be minimized proper by proper calibration, good instrument design, and correction factors. The random errors are those errors which occur irregularly and unpredictably. They do not follow any fixed pattern. These errors are mainly due to small and uncontrollable factors such as noise, slight variation in power supply, mechanical vibrations, and human reaction. For example, if we measure voltage in 5 times and get slightly different values in each time, for that variation is due to random error. We cannot eliminate random errors completely, but we can reduce the error effect by taking repeated readings and using statistical analysis. Mm. To reduce random errors, we take several readings of the same quantity. Then we calculate the arithmetic mean. Uh, the arithmetic mean is obtained by adding all measured values and dividing by the total number of readings. This means value is considered the best approximation of the true value. For example, if we measure voltage 5 times and get five different values, we do not take any one value as final result. Instead, we calculate the average value and take that as the measured value. So, arithmetic mean helps in reducing the effect of random errors. The deviation is the difference between an observed reading and arithmetic mean value. They tell us how far a particular reading is from the average value. If deviation is small, it means that reading is close to the mean and is reliable. If deviation is large, it means that reading is far away from the mean and may be affected by error. The deviation helps us to understand the uh, spread of data. Standard deviation gives more accurate measure of variation in reading. It tells us how much each reading differs from the mean value. Here, xi is the observed value and x bar is the mean value and n is the total number of readings. If the standard deviation is small, then the readings are closely grouped and the measurement is precise. If the standard deviation is large, then the readings are widely scattered and the measurement is less reliable. So standard deviation is a very important statistical tool in measurement analysis. To conclude, errors are unavoidable any measurement systems. They may be caused by instrument defects, environment, or human observation. Systematic errors can be minimized by calibration and correction, and random errors can be reduced by taking repeated readings and using arithmetic mean and standard deviation. Thank you.